All right, page 715 today. We're talking about arcs and chords. Arcs and chords. And your first rule is theorem 10-2 up on the top of 715 says in the same circle or congruent circles. Two minor arcs are congruent if their corresponding chords are congruent. And the picture will make more sense than the rule. So if we've got a circle here, circle L, and in that circle we've got chord FG, and chord FG creates this blue arc FG. And then down here we've got chord JH, and chord JH corresponds to this green arc JH. What the rule says is that the arcs are congruent if their corresponding chords are congruent. So if FG here is the same length as JH, then this arc FG will be the same measure as arc JH. So we can say if FG is congruent to JH, then arc FG will be congruent to arc JH. Now, this says two arcs are congruent if their chords are congruent. Vice versa, that is true as well, right? The converse of that would be true as well. That if the arcs are congruent, then the chords would have to be congruent also. Okay? So if the chords are congruent, the arcs are congruent. If the arcs are congruent, then their corresponding chords are congruent as well. So look down at the bottom of page 715, and they give you a circle over there. And you've got a chord AB and another chord CD, and you're told that they are congruent. And then you're told that arc AB is 60 degrees. Find the measure of arc CD. Well, since chord AB is congruent to chord CD, arc AB will be congruent to chord CD. So CD is going to measure 60 degrees. Then the example right below that says that if the measure of arc AB is 78, find the measure of arc CD. Well, now if AB is 78, what's CD? 78 as well. Good. Simple enough. If the chords are congruent, arcs are congruent. If the arcs are congruent, well, then the chords are congruent. So turn the page and look at example 2. Now we're going to introduce a little bit of algebra. We've got two circles. We've got circle J with a chord in it, and the chord is MN, and you're told that the length of the chord is 2x plus 1. Got circle K that's next to it. Circle K has a chord in it as well. That chord is PQ, and it is represented by the expression 3x minus 7. You're told in the figures that circle J is congruent to circle K, so the circles are the same. MN, arc MN is congruent to arc PQ. Arc MN is congruent to arc PQ. Like we just said, if the arcs are congruent, well, then the chords are congruent. So what we can say here is that 2x plus 1 is equal to 3x minus 7. And it asks you to find PQ. So if we have to find PQ, well, then we got to solve for x first, and then we have to substitute. So I'm going to subtract 2x from each side here. So 1 equals x minus 7. Then add 7 to each side. And 8 is equal to x. If 8 is equal to x, then PQ is going to be equal to 3 times 8 minus 7. So 24 minus 7 is 17. So PQ is 17. In the next example, just below it there, guided practice 2. Same concept, but now we've just got one circle. Chord RS is 5x minus 9. We've got chord TV. That is 2x plus 3. Again, you're told that the arcs are congruent. If the arcs are congruent, their corresponding chords are congruent. You're asked to find RS. All right, so if we got to find RS, we have to solve for x first again. So 5x minus 9 is equal to 2x plus 3. Subtract 2x from each side. So 3x minus 9 is equal to 3. add 9 to each side. So our 3x is equal to 12. And then divide both sides by 3. So we get an x that's equal to 4. If our x is equal to 4 and we need rs, we're going to substitute 5 times 4 minus 9. So 20 minus 9 equals 11. So there's rs. Questions? All right. Then let's look at page 716, theorems 10.3 and 10.4. And what we've got here is if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So in a circle, if a diameter or radius, a diameter is a chord that goes through the center. So if we label this AB and it goes through point C, it's a diameter. All right, so now we've got a diameter, we've got a chord, and here's our symbol for 90-degree angle or perpendicular. So when this diameter, AB, or radius, the radius portion of this diameter is C to B. So if a diameter, AB, or a radius, CB, is perpendicular to a chord, that's what we have here, then it bisects the chord. So look, this piece of the chord is equal to this piece of the chord. All right, let me add a point right here. Point Z. X to Z would be congruent to Z to Y. Here's what else is true. It bisects the chord and its arc. So this portion of the arc is congruent to this portion of the arc. Everybody see it? A radius or a diameter intersecting a chord at 90 degrees splits the chord in half, and it splits the corresponding arc into two congruent pieces. All right. Now, the converse of that is also true. The perpendicular bisector of a chord is always a diameter or a radius, okay? So make sure you get that in your notes. The perpendicular bisector of a chord is a diameter or radius. All right, so let's look at the example 3 down there on the bottom of the page. And we've got a circle again. We've got circle S. And we've got a chord, PR. We've got a segment QS. We're told that they intersect at 90 degrees. So if this chord is perpendicular to QS, what does that make QS? Good, it makes it a radius. So we're told the measure of arc, PQR, is equal to 98. Find the measure of arc PQ. So here's what they're telling you. Arc PQR, this arc, starting at P through Q, ending at R, is 98 degrees. Well, if a radius is perpendicular to a chord, then it splits the chord in half and corresponding arc. So the measure of PQ, isn't it going to be equal to half of the 98? So the measure of PQ equals 98 divided by 2, which is 49 degrees. And we're going to say that if, let's add point T right here. If TR equals 6, find PR. If T to R equals 6, then what is T to P equal to? It's equal to 6. And if both of the small pieces of a chord are equal to 6, what is the big piece, PR, equal to? 12. Good. Any questions? All right, then your practice for today is going to start on page 718. One through 3. 7 through 14. And we'll leave it at that.